Hello everyone. In this video, we will dive into another important topic in the Test Universe application and modules. We will share practical insights, testing concepts, and real-world examples to strengthen your knowledge and field skills. So let's get started and learn something new together. The QuickCMC test module is designed for a simple, fast, and flexible manual testing. It allows you a direct control of all the current, voltage, and binary output of the CMC test set, as well as monitoring of the binary input. Since it doesn't include information about the protection function or its setting, so the users must manually decide which signals to output and evaluate the relay response themselves. And this makes the QuickCMC suitable for basic functional checks, such as verifying the pickup and drop-off values, performing wiring check and diagnostic tests. However, for automated and efficient testing of a specific protection function, using dedicated modules like the overcurrent module, advanced distance module is highly recommended. So to start the QuickCMC, to add a QuickCMC, you can simply navigate in the test modules and tools, and you will find a direct quick access for the QuickCMC module. Or instead, you can create a new test document, or you can open, if you have a saved test document, you can open it from this icon. So for automated and for creating a customized test plan, which is highly recommended, you can click enter test new test document, and simply you will follow our OMICRON Ohm's law. So let us start with creating a new test document from scratch by using the QuickCMC. Here is the new test document. So to add a QuickCMC module, you can click on the insert test module. So you can create a new QuickCMC module, or you can create from a file. So if you have a saved module, you can use the option of create from a file, which will automatically use the existing test object and the global hardware configuration, and ensure that the module is placed below the global hardware configuration, not above or between sections, to maintain proper access to setup data. And if you load a saved module, always verify that its test object data contains the correct information. So I will create a new QuickCMC module. Then you can rename this element or this module in the navigation pane by using a slow double click. Or you can right click and click rename to give it a name, like the wiring check, for example. Okay, or you can press F2 to rename the QuickCMC test module to any name, just to be meaningful names. Otherwise, the test document and the result test report will be very difficult to understand. Then we have to follow our OMICRON Ohm's law. We will navigate now for the test module, which is the third part of our OMICRON Ohm's law, as you can see here. So here is the last step of our OMICRON Ohm's law after inserting the test module, and this orders of O and H and M applies both to the overall test document and within each individual module. So by starting any test, always verify that the test object data is complete and the hardware configuration is correct and it's active to ensure accurate testing results. And also you can navigate to the local hardware configuration. So after click the hardware configuration, it will open the window for the local hardware configuration, just to make sure the analog outputs required and the binary signals required and so on. Also, if you don't need this binary input in the wiring check, you can simply make it not used. Then you can click OK. Now we will take a look about the home ribbon and the view ribbon. So the first icon in the home ribbon, we have different options. So the first one is a switch off on trigger. So if you select this switch off on trigger, it will take this option, and it will switch with the start contact, for example, to check the pickup and the drop off signal of the overcurrent stage 1. And also we have another options to switch off on time. So it will be switched off after a specified delay time. So after clicking switch off on time, it will give you the ability to specify the time delay to be switched off after this time, just to be more than enough to take the measurement from the relay software or the local HMI of the relay. Otherwise, you can deselect this value. Also, we have stop ramp at 0, which if the fault inception happened at some point on the sinusoidal waveform of the current, it will stop after, during the next 0 crossing of the current sinusoidal waveform, to provide you the maximum safety of your test set and also the protection relay. We have also option to synchronize to input, which is input number 10. So if you need this injection values to be synchronized to a specific input, you can connect the input to binary input number 10. like the carrier receive, and once we receive this carrier receive input, we will start to inject using the QuickCMC, which is synchronized right now to binary input number 10. We have also the auto report. So once you activate the auto report, you will create automatically report after the test done. Otherwise, if you unselect this auto report, you can add it manually here using the add to report. We have also a prefault setting if you need to perform the normal operating conditions before going to the test values. You can specify and configure at 0% or 10% from the load, or 50% from the load, and it will give you 50% of the nominal current to be injected to perform a normal operating condition before going to the test values. For example, here we have specify the current to be 1 ampere, which is a nominal current, and also you can specify at 100% from the load, which is equal to the nominal current in the secondary values. We have also the start and stop button to start the test. We have the hold values, and this hold values will allow you to change the values of the voltage and the values of the current during the injection without applying this immediate values immediately to the relay analog input. So here you can add any comment to be displayed in your test report. Also, we will walk through the view ribbon. Here is the view ribbon. So we have the manage views, so you can lock or unlock views. So here is the default view about the test window, test view window, phasor view window, and the impedance view and the report view. You can also unlock this view, and you will be allowed to change for any kind of layout you need. And if you need to discard these changes, just you can apply the layout as a default, and it will return back to the default view. We have also the test view, which have the set mode for the analog output. We have also the binary output here. If you are configuring any binary output, it will be displayed here just to simulate any kind of event to the protection relay binary input, such as a circuit breaker on or circuit breaker off, or voltage transformer MCP trip, and so on. We have also the phasor view, which allows you to check the phasor view of the analog current and voltage values. We have also the impedance view, as you can see from here. So here is the impedance view, and if you change the set mode to be impedance at I constant or V constant or source impedance constant, or as a relative values in a percentage, you can specify it easily, as you can see, for example 3 line or line to line, and then you can specify the point here to be at 80% from the line length, or you can specify it from all zones or zone 1 as you like. And here is the angle of impedance. You can make it as a line angle, as you can see on our impedance view, and then you can check the constant current to be 2 ampere or 3 ampere, and so on. Also, you have the possibility to set the set mode to be direct or line to line or symmetrical component, which means positive and negative and zero sequence components, or powers, or fault values using the fault calculator. So we will go back for the direct set mode, which allows you to specify the values of voltage. Then you can select the nominal values. Then you can select by right click, you can select the equal magnitudes. Also for the current, we can do the same. Then it will give you a direct access to configure the analog output of current and analog output of voltage. And here, as we explained, we have the switch off on trigger to be switched off with a start or a trip or any kind of binary input. And then we have also the report view, which gives you any kind of tables, and the details need to be printed out in your test result. Also, we have the status history here, as you can see from here, to give you the connection status of the CMC with the test universe. Also, we have here the overload monitor to give you a direct status of about the analog output of the voltage and the current, and it will be displayed in yellow phase to indicate that there is a short circuit of the voltage channel or open circuit in the current channels in yellow color. And once you correct your wiring workflow, and you can make reset for the overload status. We have also a display buttons here, which allows you to change or toggle the time between seconds and cycles, as you can see from here. So that now the delay time is specified in cycle, and you can also return back or toggle to second. Also, the values can be toggled between primary and secondary values, as you can see from here, depends on the CT and the VT ratio in the device RIU file. Also, you can display the values in absolute values in volt and ampere, or a relative in respect to the I nominal and V nominal, which means per unit values. And again, we have also always on top, so it will give you ability to display the QuickCMC always on top. If you have any software running on the background, the QuickCMC always will be on top. So we finished the home and view ribbon. So let us go for the step and the ramp view here. So you can make a ramping up or ramping down for the current and the voltage values, just to simply check the pickup and the drop-off values of the overcurrent stage, for example. So you can select 3 line, you can select magnitude or phase, and also you can select the step size to be, for example, 6 milliamp. And we have the overcurrent stage at 1.8 amperes, so we can start with 1.7. So here is the start value of our ramp, and then we can click start and click auto step, or manually increase and decrease the current values by this step size until we get the pickup and the drop off values. So let us check practically. So we will click start. Then you can control it manually, as you can see, or you can make it auto step and define the delay time of each step to be more than the expected time. So the start is happening instantaneously, so there is no need for waiting out of time. We can make it 100 milliseconds, for example. Then after you click the arrow button, it will give you automatic increment and decrement of the current values, and it will give you the direct value of the pickup current, like 1.802. Also here you can specify the line angle. After clearing the report, you can specify the current phase angle, so you can make it 0, and then right click, then you can select the balanced angles to be 0, -120 and 120. And also if you allow and if you configure the auto step, you can use also the pulse ramp if you have a second stage of overcurrent at 6 ampere, for example. You can specify the time of each step, and you can start from, for example, if we have setting equal to 6 ampere, we can start with 5.8 for all values. Then you can specify the time here to be more than the expected trip time of the stage 2 and less than the trip time of stage 1. So we will select the trip condition of the binary input here to stop the injection and give us the result. And here is the time will be 200 milliseconds, which is more than 100 milliseconds of stage 2 and less than 500 milliseconds of stage 1. And the reset, which allows the relay to go to the prefault state and to reset the binary output of the relay. Then you can select start. Then you can display the test report from the report view, or you can adjust the report setting to be in a short form or a long form, or you can define to have a customized test report. So you can select, for example, any data to be printed out in your test result, such as the binary outputs, the analog inputs, the comment, the synchronized mode, and so on. Then it will be displayed directly in your test report after clicking start and stop. Then you can add to a report, give it a value. So it will be displayed here in your test report. As you can see, here is all the data to be displayed in your test report. If you need also to remove some tables, you can easily define your report setting from here. Thank you.